We'll start with what's GraphQL. First of all, GraphQL, as the name says, is not we'll start with is not a query language, as it would say, or it's not a database or a database querying language like SQL or anything like that. It is actually a query language, graph query language for the APIs for our HTTP endpoints. How it all started? It started at Facebook, where they were having the issues of with API versioning, maintenance of backends, since Facebook has many clients. There are various desktop versions, mobile versions, as well as the light version. What they wanted is the server to be rich, and they wanted the client to be rich, so that they can request whatever data they want from the server in a declarative way. There are quite a few companies which have been working on the ecosystem with GraphQL. So GraphQL is language agnostic. We can implement GraphQL with Node, with Java, with Python, with PHP. It's just that we have to implement the endpoints, and we need a GraphQL client to consume those endpoints. If we talk about the web specifically, we have one great company called Apollo. They are working towards making a GraphQL server and client applications. So it's they are using JavaScript predominantly. So they are targeting React mainly, and they also have a client for Angular and Vue, and their implementation for GraphQL is in Node.js for the server. GraphQL, what it allows you is to declaratively ask for data, and to fire the post request, which you'd say the mutation to change the data. So it has got nothing to do with which language we use or which database we use. I'll give you a very quick example as to this is what we call a GraphQL playground. Here I'm connected to my local server, that is 8080. I have this project running. I'll share the URL for the Node backend project and the front end project, which is made in React. So it is calling those APIs or the GraphQL endpoint and getting in the data. If you closely look at the network tab, you'll see that it is calling that and getting the data. I'll just quickly tell you what a query or a mutation is. Query is just so everything in GraphQL is a post request, and we send in our request parameters. It basically goes in like a string. For suppose if I do a query called get questions, what I'll do is I will declare fields which are on get questions. So I'll get the question ID, I'll get who is this question by, that is the username. I'll get the question title. So I don't need to even remember all these. I can just go to this and see what parameters does it accept, and what data does it return. So we can also query other things. So I'll query the body of the question and whatever tags it has. So when I fire this query up, it will return me results in form of JSON. So here I can do aliasing and get it in the shape I want it. So everything else is as it is. So even I can alias this, like I can do user. So I'll get this, this question is by this user, his ID is this, the title of the question is this. So basically what this app is, this is very functional and very trivial clone for Stack Overflow, wherein we can view all the questions, and we can give answers to those questions. We can add in the answers and we can view all the answers. So there are a few parts like adding the questions to the favorites, or upvoting and downvoting the questions. Those are still left to be implemented by me. So let's dive into the code first. First I'll show you the code with the server. So we'll start with the schema file. So this is the heart of GraphQL. It's how we define our data. So everything regarding the queries and the mutation is strongly typed. So we must explicitly define what data we want from that query, or what data are we sending, what parameters are we sending to the query and the mutation. So there are a few basic types in here, like string, int and boolean, and there's a support for JSON data type. So it's not there by default. I've added this using a library called GraphQL type JSON. It is an npm module. I just installed it from there and added the type to the resolver. So whenever it will encounter this, it will be resolved by this object. So now if we go, there are quite a few things in the schema file, but we'll quickly cover those. So one of the main things is the type query and type mutation. Here we define all our queries and all our mutations. So this is like a set of operations which are already defined on the schema, and my GraphQL endpoint will only allow these operations and whatever parameters I have written. So just to quickly brief you, this exclamation mark means that this field is compulsory. So if I'm returning a user, I compulsorily need the user object compulsory needs to have the ID. So same way, if I'm accepting any argument in the query or mutation, and I've marked it with exclamation, so it becomes a compulsory field, and the server will throw an error if that field is missing. So for this file, we have all the queries and mutations defined here, and those functions are actually implemented in index.js file. We'll jump on into it later. So we can have our own types. It's not and those are mostly combination of other types or basic data types. So here I have the user, in which there's an ID with int as a compulsory parameter, and then there's name and email, which are both are strings. And then there are other types which I have defined here. So how you define your schema is really very important. That's what would limit you or allow you to do with queries and stuff. So this notation is an array notation. So if I want multiple objects to be returned from a query, so a question would obviously have multiple answers. So it is returning the answers. So this is like a key name in which there will be an array of answers. So answer itself is a type here. If we go and see, this is the definition for the answer. So here you'd say that I have created a circular dependency kind of a thing, but the way I've handled it is in this on. I've given the question and it should be compulsory. So what it does is it only has the fields which are compulsory in the question. I don't need to define the tags inside of that. In fact, I can use the ID and the on parameter is actually accepting the ID. So I'm just mimicking the SQL behavior of normalizing the data with it. And this is what my fake data store looks like. This is just in memory, and I'm not storing the data anywhere for now. It's just that if I close the server, all the data would be gone, and we can add the data to this to these arrays. And it's just that I was lazy and I didn't want to get into databases for this, so that we can grasp the concept of GraphQL very well. So it's just normal JavaScript functions, or you can so this file, these GraphQL types remain the same for any language you want to implement your GraphQL server in. We have chosen Apollo as our server provider, and we have used Node.js here. So if we go here, this is where my server is coming from. These are various imports I have done from the server, and this is my data. So if we go to this, we have initialized the new instance for the server, and we are making it listen on the port 8080. So this is there are lots of various arguments which we can provide to the Apollo server. Two of the main arguments which are like compulsory for the server to work. One is the resolvers object, and other is the type definition. So in the type definitions, what I've done is I've just read this GraphQL file and just provided it to this. So if there are any errors, so if we intentionally write something which is which doesn't comply with GraphQL schema language, this won't go through and will be thrown an error in our console. So what are resolvers like? Resolver is anything which we have defined in our schema. So I can write a resolver for body, for upvote count, or for an answer. But the main things which we need to implement are these functions, which is query and mutation. So in the resolvers object, we have this is by the way our enum. So I have written an enum upvote value, which is downvote and upvote, and this actually resolves to +1 and -1. So we can have resolver for types, as well as two main resolvers, that is query and mutation. So inside my queries, query and mutation objects, I have all my queries. So these names should be exactly same as defined here, and they should accept, they should return the data in the format which we have defined here. So this get all tags is actually returning a JSON, so that this means I can almost return anything from this. For suppose if we go to get user, this would return a user object, so can be subset of the fields here, but this is the this is the key which should be compulsorily returned from this, otherwise it will throw an error. So if we go to this function, so all my functions are synchronous right now, since I'm reading from the memory itself. All you need to do is write async before a function and await your calls, and then when you return, the data would be returned. So there are several arguments which a resolver function accepts. First one is the parent, second one is the argument. So this is the one in which we'd be using all these arguments which are coming in. So if I need the name on from the add user, I'll have to call the mutation using some client, and I'll get the name in args.name and email in args.email. So here I've just destructed the whole object from the context. So I'll explain to you what context is. Actually underlying GraphQL, the Express, the Apollo server uses the Express node HTTP server. So if just like Express request object, we can inject anything into the context. So if there's some session data or user data I want to attach in the context, so this context is executed for all the requests which are made to the server from the clients. So here I'm just getting the user ID from the request and returning the user based on that. So here I can do any asynchronous operation and return whatever I want. So it would be available in the context object. So you can see in multiple queries and mutations I've used this context. So I'm getting the user, and whatever actions those which need authentication compulsorily require a user. So if there's no user, I'm throwing this error. This is a default error provided in the Apollo server. These are the 3 errors which are default, and we can implement our own errors as well. So I've used all the synchronous methods and just manipulated the objects in the memory itself. But yeah, let's go through all the parameters in bit of depth. So parent is essentially not very useful with queries or mutations, but say for suppose I have a field like email, so I want to do something with it, or I have a composite type like an answer. I want to add something to it, or I want to resolve some value. What I'll do is I will write a resolver for that. So this is a function assigned to it. So in the parent, it will give me the object or the query in which my answer resides, and the arguments for that. I will show you in the playground itself how the queries are fired and how we can do mutations. So this is the way to set anything in the header, and these are the query variables which we'll be using. So let's first do the mutation of add user. So this mutation accepts a name as far as I remember. Yeah, name is the compulsory parameter, and string and email being an optional parameter. So we'll have to define the types, whatever types which they have. So if I do this, it will throw an error. I'll have to compulsory do this. And then there's email. So what I'll do is assign the name to $name and assign email value from $email. And what I'll be returned is the user object. So I'll have, so I can query whatever fields I like. So let's say I don't get the emails, I don't want the email, so I won't get the email. So if you closely notice here, if there are nested types, so since by or the user is a nested type, we cannot just query whole of it. We have to specify the fields we want. So there's one beautiful thing called fragment. Let's define a fragment. We are defining a fragment on user. So we'll just name the fields here, whatever fields we like. So here what I'll do is just spread the user info here, so it will get me the user info. Same way I can do this. So this is for the reusability part, if I don't have to repeat myself. So now I'll pass in the name and the email. Since I've already have my name, it will return my ID. And won't insert a new record here. So there's some error, I guess. It won't allow us to fire the mutation. So it is saying that name doesn't appear in the GraphQL query. Yes, here is my mistake. I've missed the data type for this. So now whatever is defined here, I can either fire either of those. So let's just add a user. So this returns the ID which is already existing here, and I've passed in the email, but in my mock data or fake data I have not used the email for now, so it won't be returning anything. And anyway, we have not added the email on our fragment. Let me add that and see whether we get the email or not. So it is coming to null since it is not defined. Let me just get a new user and then see whether we are getting the email or not. So I'll just add a user. So see, I've just used auto increment in the sense that I find the length of the array and increment it by 1. So that is most about the server. You can find the code on GitHub, and I'd be more than happy to accept PRs. I know it's not super useful as of now. It was just my experiment to get started, and I'm planning to add various databases, data sources, and to modularize the code into various folders and files before I move on to something serious. Uh, yeah, need authentication. Now let's jump onto the client here. We have used Apollo client only. So this would be a React app. So if you are new to React, I'll just walk through it a little bit to you, but you just need to grasp the concepts, and it would remain the same for any JavaScript, modern JavaScript framework. So I've not learned this convention. It's just that I'm using it. I've created a folder called Graphql, and in those I've created a two JS files called index.js, called mutations.js and queries.js. So herein I've defined all my mutation and queries, just the way I'd like to fire them in my GraphQL playground. So it's actually I just tested all my queries in the playground, and then I just copied them over and pasted it here. So these are the actual queries which our client would be firing, and we'll be sending in real data to the server from here. So following are the packages we need to install first. We need to install React Apollo and Apollo Boost. And GraphQL. I'll explain to you what each of them does. So Apollo Boost is a library which has implemented Apollo client, and it's the better version, or the version which lots of defaults for Apollo client. So if we configure Apollo client by hand, we'll have to configure lots of things like the cache, the links, and various stuff. So Apollo Boost actually gets all those packages for us and implements the defaults for it. React Apollo is the package, package specific to React, wherein we are making queries and mutations, and GraphQL is the package in which we are getting this tag. So this is the modern string string template literal syntax in which we are defining our queries. So if you want to read more about it, there's a great article by Max Stoiber on it, like how string interpolations work. So these are all my queries, like whatever data, these are all my mutations actually. So whatever data I want to send in, and whatever data I want to receive back from that mutation. So essentially mutation is a insertion or updation or deletion operation. That's anything which is changing my data, and queries is just fetching the data, and I can pass various parameters as well. So there are quite a lot of advanced things you can do with the help of Apollo client, like pagination and stuff. So yeah. So there are basically two types of queries and mutations in the React Apollo client. So in the React in the React Apollo version 2.1, they have implemented something called link state. It is said to be the replacement for global state management in the React application. So previously they were using Redux as a global store, but they are now having their own implementation, and they recommend using Apollo link state. So all the queries and mutations are either on the server, like the direct queries, or we can have fields which end with at client. So we can have mutation and queries which are local to the application or the state. So for suppose if I'm showing some model toggling something and the UI state of it, so I don't need to send the data to the server or to retrieve that data to the from the server. So it would be in my local cache, and for that, for querying that or changing that data, I'll use these queries. So there can be fields which can be local. So a query or a mutation can have fields both from server and from client, but right now I've just implemented exclusively queries and mutations which are either server which either go to the server or which just go to Apollo link state, that is the client. So how I started was to create these two files, and I literally just copied the query here, queries here, and just put it in a GQL template literal. So now we'll jump to the app here. So this is the appliance which I'm getting from Apollo Boost. I've not followed certain conventions like to break my code or modularize it. For now, I just had to get going quickly. So it's in one file. I could have very well initialized it in another file and exported it and used it. So this URI is my endpoint for GraphQL on the server. So this can be configured in the environment variable, but for now I've just hard coded it, and I've mentioned the host, the port, and this is just this is not a compulsory argument. So I've just this is not a compulsory thing. I've just used it to indicate that I'm making a call to GraphQL. So if we closely look, all the GET requests to the server are returning me the HTML or the document or the playground, and all the POST requests would actually go on to the resolvers. So coming back to the code, I've used React router here, and I've used Apollo provider. So I need to wrap my entire app in the Apollo provider, and I'll just pass my initialized client to that provider. So so this is the implementation for link state or the local state, which I or the global state for the application, or state which is in my client. So this is like initializing the state. Whatever values I'm using, I can initialize them, and the same way I have resolvers in my server. So I'll have query and mutation resolvers here, and here I'll be writing to cache. So cache, so this Apollo Boost client actually implements the cache for us by default, that is the in-memory cache. If we were to go and use Apollo client. Otherwise we'll have to import the in-memory cache package and do that. So even in the documentations they have gone with Apollo Boost since it's the default implementation now, and it is the standard implementation. But this is what everything Apollo Boost actually includes. So an Apollo client is actually working on the links. So everything like a connection to a WebSocket is a link, a connection to an HTTP server is also a link. So in the end what we do is we put all the links in an array and assign it in the object while we are initializing it. So if we go to GitHub, we still have this Apollo client present, but so even there they have replaced it. So I've used the Apollo client in my project, but these are the parameters. So it is lots and lots of libraries which are being used, and so Apollo Boost is the way to go for us, since it implements quite a lot of stuff by default. So even link state is implemented by default. Otherwise we would have to import Apollo link state and create this stuff here. So other than that it is a pretty normal React app, but there's one important thing to it, that is to fetch data declaratively rather than imperatively, like making Axios calls or fetch calls. So let me just show you. If we jump onto the home page, and if I go on to show this is where all my tabs are. So if I do any filtering, it is filtering all the questions based on those tabs. So in my tabs pane, I've queried to get all the tabs. So this is the query which I've defined here. So if you closely see, this is the query which is also present in the server, and I'm getting all tags with it. Since it is a JSON, I don't need to specify the specific types or what is being returned. What I have done is instead use an alias called all tags. So otherwise the data I would be getting in the object called get all tags. So here in my component I've used the render prop to get all my tags, and this has come in Apollo 2.0 client. Here I'll get all my data here. So this render prop will fire multiple times. Initially we'll see the loader, and if there are any errors. I've not gone very deep into that right now, but if there are any errors we can display them in some components or in any way we'd like. And then this is my standard JSX. So excuse me for batch styling and doing inline styling. Uh, so uh, we have used a mutation that is to select a tag. So I have to so I have used a HOC HOC here, wherein I'm passing the mutation as a first argument to the GraphQL HOC, and name the second argument is an object which accepts various parameters, and this is entirely optional. But since if we have multiple mutations or queries inside a component in an HOC, we need to name them, otherwise it would be overridden and inside the props of the component. So here in the props I will get the method in which I'll have to fire a mutation, and variables is the object wherein I'll provide all the values which are accepted by this mutation. So if we go to select tag mutation, it accepts string, which is a compulsory argument. So what I've done here in tags is I've iterated over all tags, and on the click of the div, I've just fired this link state mutation where it will select the tag, and I've written the code that it will toggle the selection. So if we are selecting the same thing, it will toggle. If we are selecting something else, it will filter based on that. So a question can have multiple tags. So these both are like the same tag. This question has both the tags. I am not displaying the tags right now, but this is like a feature I'd like to develop as well. So we'll see how we are getting that selected tag in this component as well as here. So what we'll do is we'll go to our home container. So here I'm making a query to get the selected tag, since both my tags pane and the questions pane would require the selected tag. I've passed the selected tag as a prop to both, and this is my local data, or it's not coming from the server, since I don't need to store which tag is selected, since it's dynamic and can be anything. So it is reactive by itself. I just need to update the cache by firing the mutation. Once the mutation fires, all the HOCs which are doing query on that part of data, or all the render props would automatically fire, and the re-render would happen automatically. So this is essentially like the questions. If we go to the questions component, we'll see that here we are making a query to get questions, but we are also specifying selected tag. So whatever tag is selected, so initially there's no tag selected. If we go to the network and filter out all the URLs with GraphQL and refresh the page, so we'll see there are quite a few queries being made. So let's go to this one and see. So this is the get questions query being made. So here tag doesn't have any value, so it will be fetching all the questions here. You can closely see this is a string going on. So the operation name is the name for the mutation or the query, and the query query or mutation itself goes in the query. So this is a request parameter, and the server knows how to